Hello, and welcome to more confusing computer talk with Troy, where we ask important questions like, what is a computer? I think about all of this stuff I'm trying to build, like input devices and things like that, and just things for tracking little bits of data. And of course, it starts off very high level. Well, obviously, you want to have like an entire computer that you carry around with you in the palm of your hand, and it steps down from there. But the question that I'm more interested in asking is, what happens when you go all the way to the bottom and start working your way up, rather than, the most complex, the most features, the most everything, and the most code? Complex is, of course, a positive and a negative. But I think about it just makes me think about when I start to simplify things, I realize I'm still simplifying things within the context of what I think a computer is and should be, and what my experience with computers is, or has been, I guess. Like, you don't know what you don't know, first of all, but you're also probably not quite aware of the things that you take for granted. When I say computer, a thing pops into your head, and then everything I say after that is applied to that thing, that concept or that picture or whatever you get when I say computer. The point is to take that and turn it upside down. Let me see if I can do that. See, what about a computer designed to grow a plant? Kind of works. I don't know. Nothing's coming to mind, and that's the problem. I can't step out of my own context. I can't step out of the paradigm that my brain shifts into. I'm in third gear, and I'm like, I wonder what it's like in fourth gear, as I sit here in third gear going, let me ponder fourth gear. I get some of this from Alan Kay's sad defeated comments, and they're not like he doesn't have one specific talk, but you hear him talk about what the direction turning left, the direction the industry has gone, and then he's just like, yeah, we missed a chance. And people are like, but what if the computer had a different language installed on it? And he's like, guys, let's start at what if the computer, let's start at what if, maybe. Like, the way he talks about this stuff, it seems like he's very deeply saddened by the state of modern computing. And when people try to talk to him about it, and I think I've seen this in multiple interviews, he's just like, you need to rethink everything. You need to start at the beginning. And that's kind of what I'm trying to do. It's like Alan Kay is on Mars, and he's trying to explain to us how great Venus would be to live on. And we're on Earth, and we can't hear Alan, and we can't see Mars, and we don't even have a concept of Venus. That's like the level of separation that's taking place here. I don't even know. Like, even just manufacturing, all of it has just, it all follows a specific vein. It's like no one's going back to tube computers as far as I know. Transistors are just fine. Using silicone to generate CPUs is just fine. But that's all pure hard logic. That's not, that's not the soft stuff that goes on top of it. So it would be like saying, well, what if we make some chips that use tree bark? It's like, okay, cool idea, interested in checking it out. No one can do that, and it's impossible right now. Like, It's not even an option in this industry. There's no manufacturers coming even close to that, and there's no manufacturers who would even give you the time of day to consider helping you to create this. And that's the state of the industry. So the question is, how far above, what if the computer had a different programming language on it? And, what if the computer had 64 million colors rather than 32 million colors? It's more like, what if, or like, what? The base of the question is, what? I don't think I slept very well. This is not funny. What? That's more the response. Like, what if we made the computer out of tree bark? What? So, like, how far above what do we have to get in order to get something that's, viable in the industry? Like, right now I'm looking at ASICs, and like 8-bit, 16-bit ASICs, and like, I don't even want to, like, I think about this and I'm like, okay, like, an ARM processor is probably the place I'd wind up, but I don't even want an ARM processor. I want lower, I want less complex, there's still my own personal beef with the complexity. Like, the ARM processor is very powerful for what it is, and it's new, and I don't like overpowered, and I don't like new, just because I don't know, there's lots of weird stuff going on with tech these days, weird, like at the silicone level, and I don't like any of that. So, like, an Atmega 32U4 is probably just fine. Now I'll have to look into the ESP32s. Those are still interesting, but I don't know. So how far above that do we have to get in order to be able to at least interface, be somewhat practical? This can't all be theory. But how high do you have to get to be practical, to be able to use current hardware, or at least, within the last few decades, hardware, and still keep it simple and be, somewhat extensible, I guess. Have some room for growth. See, the other thing about this is if this is written in, not Android, Arduino or some other meta language, it opens up the possibility of making a face for this, and then just making the MCU swappable. Run it on a Pro Micro, run it on a TNC, run it on a Blue Fruit, run it on whatever. You start making something that is a base for building upon, software wise. And then if someone wants to add this feature or that, then the answer is sure, it's Arduino. Add it yourself. The equivalent of RTFM. I don't want to be all curmudgeon-y, but like, that used to be like literally all you got out of people was like RTFM. And now it's like, whoa, why don't we generate a meta language for you so that you can understand, C is great, but have you tried JavaScript? Oh man, if you've never seen Sam Hyde's TED Talk, that was one of the funniest things I've seen minute for minute in a decade. Yeah. He has an awesome line in there about JavaScript. My God. Oh man. Yeah. So, like, how high level can this be and still be kind of liberating? Because You don't want it to be isolating, though. That's the thing. Like that was part of the problem with the true object-oriented object-oriented model, and like the Lisp machine is, it wants to know everything, and it kind of needs to know everything. And there's ways around that with protocols and standards, but like everyone just kind of develops everything kind of however they want. So being able to interface with other boxes was kind of the issue. And it was just kind of isolating. So there needed to be a standard of some kind, like a bare minimum, to be able to say, all right, at least we agree on this. So what you do above that, whatever. That's all up to you. But the idea of being able to, whatever this device is, I don't want it to be isolating. I don't want it to be isolated, at least, maybe, unless you want it to be. The potential I had, or the idea that I had, was to create this device that receives input. And again, this is the core of all this, is like, what is a computer? What is the basic functionality that we ask out of a computer? Now, doing simple mathematics is neat, but not particularly helpful in this context, because we're talking about, if I spend hours and hours of work and generate a calculator, and it's like, okay, congrats, I guess. What else you got? So what is the feature that's sufficiently advanced to be useful, to be improving your life, and to be able to be not very complex, simple enough for other people to understand. Sorry, the bit about the RTFM was realizing that if without the hand holding, you're required to learn stuff, and then that, I guess, like, I don't want there to be a high bar of entry, but there has to be a minimum, I guess, is the problem. Maybe that's the issue. There's like zero understanding beyond like layer 7 or beneath layer 7. And that allows anyone with knowledge below layer 7 to just be like LeetHex, or like, amazing, I did this, wow, what did you do, how'd you do that, let me try to replicate it, let me open my Chrome browser first, and now tell me where to go. I don't feel like any of this makes any sense. I'm probably going to watch this later and be like, oh yeah, of course, perfect. I mean, at its most core, at its most basic, let's see here. I did a little bit of writing. Come on, computer, or briefcase. This is a computer. Oh, this is moshing. Yeah, that's not local. Yeah, I can't view that right now. Okay. Never mind then. I can save the input, but I can't watch it. I can't replay it right now. So that was a device that was connected to my server through a mosh session, so it's persistent, and it will store the input while it's disconnected. But my object was to just be able to dump notes out of my head. And I just wanted to reference them right now. So like, what is the optimal way to get that data out of my head? So the base of this computer is going to be, and I guess, if you're a hammer, every problem looks like a nail. If you're a keyboard designer, every solution looks like a keyboard. But I don't know quite how to get around the input problem. Like, you've still at least got a 40%. I mean, you can go like full corded keyboard full corded one-handed keyboard, that kind of thing. But I don't think it's fast, and fast is the problem for me. I type faster than I write, and I think faster than I type, so I just have to get it out of my head as quickly as possible, and then I can review it later and put it in better context and apply and mix the ideas together. So this computer, what is a computer? It takes inputs, usually digital inputs. It applies logic to them, and then it generates an output, preferably an output in a manner that is understandable to humans, whether it be blinky lights, whether it be a display, whether it be lights that take the shape of letters that are understandable to humans that read certain languages, or whether that output is a conversion output of data that goes to another computer to read and understand and translate into something that goes to another human. Or at least translates into controls that a human would produce at a faster rate than a human could produce it or calculate it. So if I were to, do elliptic curve cryptography on a sheet of paper, and use some kind of PFS system so that each problem relies on a seed from the last problem, then to translate a paragraph of information might take several weeks. To translate a kilobyte of information might take several years. But a computer can do that in seconds, or less than seconds. So that's certainly something that just the straight math, but that's not quite what I'm interested in. I want to get... Well, there's also like the translation of like picture data. When we take a picture with a camera, in an original camera, it translates light into different shades or hues of light, basically, on a film, and then that's translated and blown up onto a sheet of paper that represents the colors more closely. When we take a picture with a digital camera, it takes those points of light and turns them into ones and zeros, which is not very useful to humans, nor is the hex dump of a JPEG. But with a display and a computer to translate, to detranslate and retranslate, I guess. I'm not sure how we would put that. But you take those ones and zeros and give them to a computer and give the computer a display that can translate, stuff that humans like to see or are able to see. Then you create these points of light which coalesce into a picture. You're making this mosaic out of this data. And when you blur your eyes, kind of, or at least when you make the pixels small enough, it becomes a picture. But it's all just data. This is something that one of the primary concepts is that perfect data, that perfect memory. And this is, if you have a book, that book has perfect memory. That book can be read and reread by anyone who is capable of reading it, and it will always have the exact same data within it. What is the benefit of having this as an electronic book? Well, obviously, you're able to update the information, change things around. Well, this is interesting. I think the gate fell out. Oh, maybe they fixed the sensor. So a gate is drawn across this this entrance, and that gate is controlled by a computer that reads sensor input and then determines whether or not it's going to change its state to cause the gate to be drawn open. As the gate draws open, it constantly updates the state from another sensor that says, is the gate completely open? Is the gate completely open? And while the answer is no, the answer is continue opening the gate. And when the answer is the gate is completely open, then stop. All stuff that a human could do, and frankly, all at a speed that a human could process it quite easily. But I guess it's just the speed that's really the trick and the power, and the translation of data and the perfect memory. You know, if you hand a pencil to a sufficiently talented artist and hand him a sheet of paper, he'd probably be able to reproduce on that piece of paper a two-dimensional image. But think about it from the perspective of like a video game, where a computer is generating a simulation that actually creates within you a mental state, an experience of of being inside that video game. Or at a more basic level, a game like NetHack, where the output is being translated, partially through your brain, in order to create an experience where when you see a capital L, your heart rate goes up. It's all very interesting. Think about the transition of Dungeons and Dragons, like pen and paper Dungeons and Dragons, into NetHack, or something digital, or something that's distributed across the internet. It's essentially the same process, though. You're all just sitting down at a website. You're sitting down in the same in different locations, experiencing or sharing an experience. And the computer is facilitating that. Skype. Any type of teleconferencing. That's all just the same process. You're creating a simulation of that experience by supplanting or supplementing sensory input in the human. It's basically a tiny form of virtual reality. In this little square, we're going to create perceptions for you, visual perceptions, audible perceptions, the appearance of motion by multiple images being flashed in sequence, audio. I don't think there's any tactile feedback. There's no smell or taste just yet, but it's just taking those senses and projecting them outward, or placing them in partial control of something else. That's interesting.